Swayam Prabha. Digital India. Educated India.
Okay, welcome back. Now we will discuss own price elasticity of demand quite exhaustively, how we can measure that given a demand curve, how we can measure or whether that own price elasticity of demand along the different points of a demand curve is same or they vary. All those things we will discuss now quite exhaustively. Okay. So, if you know the little bit calculus, so we told that own price elasticity of demand as denoted by say E subscript P, that is delta QD by QD by delta P by P. This into numerator it was 100, denominator is also it was 100, that 100 was due to percentage change, and that if you simplify that will be delta QD by QD into P by delta P. That also if we can write further delta QD by delta P into P by QD. Okay. So, if you in calculus notation we can write that del QD del P into P by QD. Okay, that way, because that delta amount very in the limiting sense when it is a continuous kind of your demand curve is continuous, right. It is a limiting sense, very small change, that sometimes that change delta QD is denoted by del Q. No. So, using this calculus notation we can write this way as well. So, we will use this fundamental calculus in certain cases which will to give you more fine tuned understanding of certain concepts which we will discuss here in this course. Okay. So, if you have people who already have some calculus understanding, because as I already mentioned earlier, this course target audience is the undergraduate engineering students, right. So, so all of you have this calculus exposure, I am assuming. Of course, if you do not have any calculus exposure like others who are not engineering student as such, so you look for those you can still proceed with this delta notation and to understand on your own. In fact, the book we are following, that book does not use this calculus notation, but we will use in certain cases calculus notation that will fine tune our understanding that way. Okay, that will be very easy to understand for you people. Okay, in that way. So, this is our elasticity of demand. Okay. So, now let us try to measure that elasticity of demand taking a usual demand curve. Okay. So, suppose we have this kind of demand curve, usual downward sloping demand curve. So, of course, quantity demanded we are measuring in the horizontal axis, price we are measuring vertical axis as usual case, and suppose this AB is our demand curve. So, we are taking not only it is an usual demand curve or downward sloping demand curve, for the time being we are taking it is a linear demand curve also, it is a straight line. Okay. And we will try to find out what is the elasticity of demand or own price elasticity of demand at various point of that demand curve. Okay. To be specific, look at here what is the definition of elasticity of demand. Okay. This is the definition of elasticity of demand. This or this, whatever delta or del, whatever notation you are using, right. Now, since it is a straight line, I can tell slope of the demand curve here, slope of the demand curve here, slope of the demand curve everywhere slope is same, and that slope is denoted by del P by del Q. This curve slope is del P by Q because P is measured in the vertical axis and Q is measured in the horizontal axis, del P by del Q or del Q D, whatever it is. Okay, what is our notation? Okay. So, since slope, and look at here, the slope or reciprocal of the slope is only one component or one part of the entire elasticity component, right. So, this is constant, means at say point say C, D and E, 3 points we are taking on that demand curve. At C point, at D point, at E point, all the points delta Q D by delta P or del Q D del P, whatever, okay, those things are same at each of those C, D and E point. But look at here, at C point this is the P and this is the Q, this is suppose O, okay, suppose say M. So, at C point, okay, at C point P is CM distance, vertical distance, and QD is basically OM, horizontal distance. At D point price is basically dn vertical distance and QD is basically ON horizontal distance, and similarly for E point. So, if each of the C, D, E point, if you take this ratio, the remaining thing price by quantity demanded, it is continuously here. At C point price by quantity demanded basically this distance by this distance. At D point price by quantity demanded is basically this distance and this distance. So, that price by quantity demanded, if you compare that at C point and D point, numerator is falling and denominator is increasing. Here at C point this was the numerator, this was the denominator. At D point this is the numerator and this is the denominator, right. At E point this is the numerator and this is the denominator, right. So, as you are moving from C point to D point, D point to E point, all this ratio price by quantity demanded, P by QD ratio, numerator is continuously falling and denominator is continuously increasing. So, P by QD, that ratio is continuously falling, right. So, as a result we can tell at the C point whatever the elasticity of demand value, at D point elasticity of demand value is less. Of course, own price elasticity of demand we are talking about, they are less, okay, less in, okay, let me clarify, when we are telling less in absolute number, because in all these cases elasticity of demand value is negative. Why negative? Because look at here, when you are moving from C to D point, so suppose C to D point you are moving, right. So, your quantity demanded is increasing by this, okay. Let us go to the next, another appraise diagram, okay. We are measuring Q or QD, whatever, Q that side, price that side, this was our demand curve AB, and suppose this is C point, this is D point and this is E point, right. So, our elasticity of demand, own price elasticity of demand is del Q by del P into P by Q, right. QD we are writing now Q simply, okay, to avoid or complexity in the notation, okay, for ease of our understanding only, okay. So, at C point and at D point both the cases this is the same, okay, but this thing is larger at C point vis-a-vis at D point. So, their product, okay, one component is same, another component is one point is larger, another point is smaller. So, their product elasticity at C point should be, so I am telling elasticity, own price elasticity at point C definitely should be greater than absolute value, own price elasticity at point D, its absolute value. Why absolute value? Because look at here, so when you are moving from C to D, that side, your delta Q is what? Delta Q definitely greater than 0, positive, because at C point this is your quantity, at D point this is your quantity. So, D point quantity minus C point quantity, that is the delta, meaning delta Q means that, right, change in quantity, right. So, that quantity is positive, change in quantity is positive. Now, the price dimension, if you see, C point to D point, at C point this was the price and at the D point this is the price. So, if you consider delta P, later price minus the initial price, right. So, later price is smaller, earlier price is larger. So, definitely delta P is less than 0 in this case. So, this is okay, whatever value del Q. So, del Q del P, that thing is negative along with any point of that straight line AB, that demand curve, because that is the slope is negative, okay. And P by Q is always positive, it is a fraction, but it is always positive, both price and both quantity, both are positive quantities, right. So, that this is always positive and this is always negative. So, their product is always negative. So, one price elasticity of demand is always negative if we take a usual demand curve, downward sloping demand curve, right. Since price is increasing, quantity is falling, means price and quantity is moving opposite direction, elasticity, one price elasticity of demand will be always negative if we take a usual demand curve, downward sloping demand curve, right, that is understood. So, when we are telling, so that is why when we are telling that elasticity value at C point is larger than elasticity point value as D point, okay, definitely that larger in the sense that absolute value sense, right. Now, that absolute value in C point elasticity value and D point elasticity value, why C point elasticity value is larger than D point elasticity value, I hope everybody understood, because this P by Q ratio is more at C point vis-a-vis at D point, although del Q by del P, del Q del P, that value is same at C point and D point, both the points are same, okay. So, what we are getting a message, even if we have a straight line demand curve whose slope is not changing along different points, okay, one price elasticity of demand, or more specifically absolute value of one price elasticity of demand is changing from one point to another, okay. Now, the question is, since it is changing, what is the absolute elasticity value at C point, that is not the same at D point, that is not the same at E point and so on. So, how we can measure at various points of that, okay, at C point what is that value, at D point what is that value and so on, how we can measure, okay, that is our agenda now. So, let us take an afresh sheet to clarify that how we can measure, okay, fine. So, we are measuring quantity in the horizontal axis, price in the vertical axis, and suppose AB is the demand curve, okay. So, look at here, suppose we are at the K point and L point. So, we are moving from K point to L point, okay. So, definitely suppose this is O and this is say Z point, this corner is the Z point. So, definitely here delta Q is ZL distance and delta P is ZK distance in this particular case, okay. And price at K point, price is okay, okay. So, suppose Z say T1 and T2, these 2 points, okay. So, at K point, okay. So, moving from K to L along the demand curve we are going, okay. So, of course, if we move from K to L along the demand curve, given demand curve AB, delta Q is ZL distance, delta P is ZK distance, okay, and P was definitely, since you are starting from K point and landing to L point. So, from which price this change delta Q and delta P is happening? Definitely initial price we have to consider, that is KT1, okay, and initial quantity we have to consider, that is OT1, okay. So, now if we plot that delta Q by delta P into P by Q, whatever thing we will land, that will be the elasticity value at K point. So, you are moving from K to L, you are getting some elasticity value. Alternatively, if you move from L to K within the same segment of the demand curve, rather you are moving from the opposite direction from L to K. Look at here, delta Q and delta P in both the cases will be the same distance with the opposite sign. Earlier delta Q was positive, now it will be negative, and delta P earlier was negative, now it will be positive, simply the opposite side, but distance will be the same, right. But so in this particular case, when you are moving from L to K, that time what is the initial price and what is the initial quantity? So, initial price definitely in that case price will be, initial price will be LT2 instead of KT1 earlier, okay, and initial quantity will be OT2. So, look at here what we are getting within the same segment of a given demand curve, that segment is KL denoted by in this picture. If you move from K to L, whatever the elasticity of demand value you are getting, if you move L to K, you are getting a different elasticity of demand value, right, because that this value is different from where you are moving. If you move from K to L, we have to consider this P by Q, that ratio what was at K point. Alternatively, if you move from L to K, you have to take that original P by Q ratio, what is that at L point, right. So, depending on that, and since delta Q delta P value just one is getting positive and another is getting negative, or they are simply changing their sign, but magnitude is same. So, two different elasticity value we are getting. So, sometimes midpoint method is also used, midpoint method, which is discussed in your book, midpoint method. So, first we introduce, or let us clarify ourselves why midpoint method may be thought of some sensible way to capture this elasticity, because within the same segment of the demand curve, if you move from one point to the other, one elasticity value you are getting. If you move from other point to this point, coming back within the same segment, you are getting some different elasticity value. So, to avoid that, we can have that, say, okay, within this segment what is the elasticity value. Don't take, or let us don't take that this point price by, what is the price by this P by Q ratio, what is at K point, we do not consider. Let us also do not consider what is that value at L point. Rather, let us consider what is the in the midpoint between K and L, what is that P by Q value. In any case, del Q del P, that will be constant along the entire line, because it is a straight line we have considered. Okay. So, that will give you, we have to take the middle of that, means basically midpoint in between this and midpoint in between this, that will be, because it is a straight line. So, this at this point whatever P by Q value that you take, or in a sense that, or alternatively this distance you take, okay, in this green color, this distance you take at the as the price, and this distance you take as the quantity, that to get this P by Q component. And this, so in any case you have this is the delta Q and this is the delta P with appropriate sign, right. So, that is the midpoint method. Midpoint method is telling that you take the middle of the 2 points within which movement is actually happening. Okay. But midpoint method is little bit, what should I say, more crude kind of way to measure, that is one measure, although that is there only in your book. Let us now discuss the actual method, because since we are moving, if we move from K to L, that is capturing one phenomenon. Alternatively, if we move from L to K, it is capturing completely different phenomena. So, those things should be captured by the different elasticity value. Okay. So, at K point what is the elasticity value, at L point what is the elasticity value, and so on. Does not matter whether from L point I am moving this direction or we are moving that direction, does not matter. Okay. Each and every point, how we can calculate the elasticity value, let us discuss that. that is called specific method or point method. Okay. Instead of that, this is basically called midpoint method. So, let us go to discuss now the specific point wise elasticity value, how we can calculate. Okay. As usual, we are measuring quantity in the horizontal axis, price in the vertical axis, right, and we are still taking a straight line demand curve, say AB. We are interested to know what is the elasticity of demand, price elasticity of demand value at say point, say this point is say suppose K, at K point. Okay. So, of course, since we have to know that delta Q delta P, okay, since we since we have to take delta Q delta P, right, since it is a straight line, okay, so that delta Q delta P does not matter which directions I am going, this side, that side, because that straight line by virtue of its a straight line, its slope is fixed. So, delta Q delta P, this ratio is always the same at every point that we told earlier, right, because that is the slope of the line, or this more specifically reciprocal of the slope, because we are vertical axis we are measuring P, right, reciprocal of the slope. So, at this point what is the elasticity value? Then definitely that depends on this price and this quantity value. So, O K, suppose this is M and suppose this is N, suppose this is L and this is O. Okay. So, let us take that this is our say Z. So, suppose we are taking that Kz is the delta P of course, okay, ZL is the delta Q of course, right, and we are taking Km as the original price. When we are taking Km is the price, that means we are telling that we are moving from K to L point, right, this side we are moving, okay, and definitely OM is the original quantity, right. Okay. Suppose these 2 points are S and T. Okay. Now, so as per the own price elasticity of demand, that will be del Q del P into P by Q with a negative sign of course. So, for the time being we are, so I am writing absolute elasticity value. Okay. So, that must be del Q del P into P by Q, that is the definition. Now, instead of del Q del P, I am writing del Q is basically ZL, del P is basically KZ and into P by Q is P is basically Km by Q is OM, right. Okay. Okay. Now, look at here, by virtue of the fact that triangle KZL and triangle M and triangle KZL, yes, that triangle and KMB, these two triangle. So, KZL means this small triangle and KMB means this big triangle, right. So, clearly we are seeing that these two triangles are similar, they are similar triangles. Okay. But by the properties of the similar triangle, we can surely tell that this by this ratio, definitely this by this ratio, or say Kz by Zl, that must be equals to Km by Mb, because Kzl and Kmb, these two triangles are similar. So, that is why Kz by Zl must be equals to Km by Mb, that is from the properties of the similar triangles. So, that we can write Zl by Kz, just the reciprocal, both side we are taking, that must be equals to Mb by Km. Now, instead of this Kz by Zl in elasticity of demands equation, if we replace this by this, because this is this, so this and this are same, so this thing we are replacing by this. So, that will be Mb by Km into Km by Om, right. So, this Km cancel out, we are landing Mb by Om, right. Now, Mb by Om means what? Mb is this distance and Om is this distance, right. Let us now consider another pair of triangles. One is triangle KMB and triangle KTA. So, this downward big triangle KMB, this big triangle, say red color, that triangle we have drawn, no, this big triangle and this blue color triangle, say this blue color triangle KTA, these two triangles are also similar. So, the by virtue of their similarity property, look at here, this OM this distance and KT distance are same. So, instead of OM I can write here numerator is MB as it is, and denominator instead of OM I am writing KT, right. Now, so it is basically this distance by this distance is the elasticity value, absolute elasticity value. By virtue of that fact that this triangle and this triangle are similar, can I tell that MB by KT is exactly equals to KB by KA, because these two triangles are similar. So, this by this, definitely this distance by that distance, right, from the similarity property. So, what we are landing? We are landing that if we have a linear downward sloping usual and straight line demand curve, at a point what is the absolute value of the elasticity of demand or own price elasticity of demand? This distance by that distance. That message we have proved here. Okay. Let me summarize that thing, okay, using a phase diagram. Okay, suppose this is our demand curve, downward sloping or usual demand curve, but straight line also. At this point, absolute value of the own price elasticity of demand will be this distance by that distance. At this point, absolute value of the elasticity of demand will be this distance by that distance. So, if you have a straight line downward sloping demand curve, it will cut the two axes, two vertical axis and horizontal axis. So, its segment, that elasticity own price elasticity of demand's absolute value at a point on that demand curve is basically distance from that point to the vertical horizontal axis where it is cutting, that demand curve is cutting, by the distance of that point from the vertical axis where demand curve is cutting. This is the vertical axis where demand curve is cutting. Okay. So, that is the thing. Using that result, we can tell that definitely at B point that elasticity value is 0, because down lower portion is 0, upper portion is the entire AB distance. at A point it is infinitely large or undefined, because lower distance, lower point is, numerator is AB and denominator is 0, right. So, A point, that own price elasticity of demand is infinitely large, or sometimes you can tell undefined. At B point this is 0. At the midpoint of this demand curve it should be 1, because lower and upper the same distance, it should be 1. At the midpoint of this AB demand curve, it should be elasticity value of 1. So, suppose this is the midpoint, say C point is the midpoint, any point in between CB segment, elasticity value is less than 1, any point in between CA segment, elasticity is greater than 1. This is the thing, right. So, we can easily find out, given a straight line demand curve, at various points on that demand curve, what is the absolute value of own price elasticity of demand, right. Now, the question is, what is the guarantee that in real life whatever demand curve we are facing, although it is usual or downward sloping, it will be a straight line demand curve? Alternatively, or I can pose the question in a different way, suppose we have a downward sloping usual demand curve, but it is not straight line, it is a general hyperbolic curve. So, how we can measure that? Okay, so, to measure that, what we have to do? Okay, suppose say this is our demand curve, suppose, okay, this is our demand curve, which is a general hyperbolic kind of demand curve, but it is not straight line. At this point I want to find out what is the elasticity of demand value at that point on that demand curve. So, advice is that you draw a tangential straight line on that demand curve at the point at which you want to find out own price elasticity of demand, and treat elasticity or calculate elasticity of demand value as if your demand curve is this tangent. So, whatever value you will get at A point, see, if your demand curve, say maybe Mn is your demand curve in the diagram, you can easily find out what is the elasticity of demand at A point. That value will be the elasticity of demand at, or absolute value of own price elasticity of demand on the demand curve, say D1 demand curves, hyperbolic demand curve at point A. So, today we have very elaborately discussed, given a demand curve, does not matter, given an usual demand curve, does not matter whether it is a linear or it is non-linear, how to find out own price elasticity of demand on various point on that demand curve. If it is straight line, it is very easy, lower segment by upper segment, okay, the point where you want to find out the elasticity of demand value, consider the ratio of the lower point in the numerator and upper segment is the denominator. If you are unfortunate that demand curve is not straight line, rather is a general hyperbolic kind of non-linear demand curve, the point on which you want to find out elasticity of demand, at that point draw a tangent on the curve given to you, on the demand curve given to you. Treat that tangent as if the tangent itself is your demand curve. Find out elasticity of demand on the given point, okay, treating the tangent itself as if it is your demand curve. So, tangent is a linear line. So, you can easily find out following the lower portion by upper portion. So, on D1, along the D1 demand curve at point A, own price elasticity of demand's absolute value is basically AN EP, its absolute value is basically AN by AM, that is it. Okay. Although you are asked to, or you have been asked to find out elasticity of demand value at A point on the demand curve DD1, okay. That is the message, that is the learning you keep in your mind. We will discuss or we will play around using different types of demand curves and their respective elasticity of demand value in the next lecture. Let us stop here today and take care.